Whenever we're passing a value to a function, we're either passing it by a reference or passing it as a value. And to understand these properly, we need to understand what is a shallow copy. When we assign a value to any variable, we're actually storing in the variable a reference to the actual object, unless it's a primitive. Let's say that we assign the copy to two different variables. Let's assume that we have this class called passArgs, and in this, we're gonna have an array that we're gonna have, I don't know, 23, 56, 34, just as simple values. If we did original or int copy is the same as the original. In the copy, we could say that we're gonna modify the first element of the array and say that it's 10. Arrays to string, we're gonna call this original. So we're gonna print both arrays and a separator. That way we get to see the copy versus the original. And both arrays got modified. In this case, are pointing to the exact same object. What is happening here is that we have created an array, and we have created first 23, 56, and 34. And then we assigned whatever the memory is to original. And then we said that whatever original is pointing to also pointed to copy. That's essentially what we did. We assigned it to both. So then we said grab whatever copy is pointing to and replace this guy for a 10. And then we later printed out whatever original was pointing to, which is this 10, 56, 34. And then whatever copy was writing to, which is this the same thing. So we can see that here we did a very shallow copy, because instead of having this, creating another copy of the thing in 34, and then modifying this guy, and then having two different arrays with two different values, it was just a shallow copy because he just copied the reference where it was going to. So that's the difference between a shallow copy and a deep copy. Then, how does this relate to functions and passing by arguments and passing by values? Let's assume that we have an object. This is our object that could be an int, could be a long, and could be another object. And obviously, because it's another object, it has its own tree of member objects, where let's say it's a string, and then another object, and then it could have an int, long, and an array. So if we were going to, every time that we do a function, to copy this entire thing and pass it around as a deep copy, the computer would have a really hard time, because it would be a lot of work to start copying first, like going all the way down to the tree, creating this copy, then creating this exact replica, then creating this exact replica, then creating this exact replica, and then calling the function. That would be a lot of work. So Java is a little bit lazy in that sense, for the sake of performance, that it only passes what it knows what is the size of that data type. So for example, it can pass a primitive as a copy or reference, and because this is an address in memory, it knows the size of the data that it's going to copy. Same thing with these guys. These are like an int has a fixed data size, a char the same way, a long has a fixed data size. So anything that it knows what is the data size that it can pass around, that's what it's gonna. That is what is the only thing that is gonna copy and pass it as an actual replica. So, for example, let's do the same thing now without an array. Let's do a 10 or a 16, and let's just declare this guy and declare it that way, and then we're going to print two different values if we did this. Because Java only copies the data sizes that it knows. It only copies what it knows and can predict. An object is too difficult to know how to predict it, or even an array. So because it doesn't necessarily, like, off the bat knows the size, so it would have to perform a lot of operations. So if it knows just this immediate, what is the full size, it's gonna create a copy. So in a pass by argument versus pass by reference, let's say that we public pass by reference, we can say, and then public void pass by value. In both of these cases, we're gonna increment this variable. So let's assume we have this class. In this case, what we're trying to do is that let's assume that we have this class. In both functions, we're gonna try to increment the x from reference, but the very difference is that in one, we're gonna be passing the entire object, on the other one, we're just gonna pass the value. And we're gonna then attach a debugger to see how it is incrementing that data. So in the pass by, so let's call pass args this static function, pass by reference, and then we're gonna pass the pass by object, and then we're gonna do the same thing, and we're gonna do it pass by value, and we're gonna do pass by dot reference, and then we're gonna attach a debugger right here, right before the function happens. So let's look at it. What happens when we, right now the pass by reference is 0 because that's what we initialized. So if we go into this guy, the reference for this object incremented to 1 because of this, and because it was as a reference, we ended up modifying the actual object that we are passing. In other words, let me draw it this way and then I'll switch. In other words, we have this pass by, and this has a member that is called an int reference. Since we passed this entire object, we can modify this variable and it will preserve because the object is still alive. That means that we pass the pointer to this object. You can actually see it here that we passed at 466 inside. So that's the argument. X is called pass args at 466. It's this guy. It's this guy. So if we continue the x.reference equals 1, then the next function, once we left that and came back, pass args is the same object that we have, but we're gonna pass the reference value, which is 1 because we incremented it in the past. So in this case, we are going to see that it increased to, it's going to increase from 1 to 2 after we went to the next line. But when we came back to the end of the function, pass by reference is still 1. That means that the object, the value got copied here, got incremented and discarded the moment that we came back, as opposed to receiving a reference, modifying whatever that reference points, and didn't get discarded. Well, the reference got discarded, but since the object is still in scope here, that object still got modified. So again, we passed the reference here because it's an object. Then we modified wherever that reference was pointing to. That reference got discarded when we got that, or wherever the value that we were storing that reference is got discarded, not the reference itself, because this is still in scope. We finished that function and then we did preserve the value. That's a very key difference between pass by reference and pass by value. So as we can see, a deep copy is an exact duplication of objects as two completely different, occupying two different blocks of memory. If one is modified, then the other one is modified. To perform a deep copy is an expensive operation, especially with objects where it might require their tree references to be copied and duplicated until there's no more children objects. Notified about these videos as soon as I upload them, just subscribe to this channel.